Our next exercise to look at here with ellipses is number 4, where we're going to find an equation for the pictured ellipse there. And I copied the picture onto a separate sheet. It's a little larger. And so what we want to do is find an equation for the ellipse that's pictured right here. And notice that we can see what the intercepts are without too much trouble for this ellipse. And also, I think we want to notice that the major axis is on the y-axis, minor axis is on the x-axis here, right? Because the the y-intercepts are further away from the origin than the x-intercepts. Now, this is only going to take a second to write down this equation, because the standard form is x squared over a number plus y squared over a number equals 1. I just have to fill in these denominators in each case. And I think by now, if you've worked through the previous exercises, you know that the denominator below the x squared is related to the number where we cross the x-intercept. In fact, I can just square this 2 squared, and of course that'll be 4 in a second, to get that denominator. The denominator under y squared is just going to be the square of this y-intercept value, 4 squared. So if I write x squared over 4 plus y squared over 16 equals 1, there I got my equation. Now, if you weren't sure if you set this up right, you could check and see what the x and y intercepts are for this equation we've just written down, but we got it. So let's move on to number 5. Find an equation of the ellipse having vertices 0 plus or minus 7 and foci 0 plus or minus 5. I might just draw a picture here. I'm not going to draw it super accurately. Let's just say, so 0, 7, and 0, negative 7 would be points on the y-axis, right? So our ellipse is going to have some sort of shape like so. And since the foci are at 0, 5, 0, negative 5, well, if the foci are on the y-axis, that means the y-axis is the major axis. And now what we got to do, though, to get our equation set up is we really want to find these x-intercept values. In fact, I can say a little bit about what the equation is already. X squared over something squared plus y squared over something squared equals 1. Because we already know the y-intercepts, these vertices, I know the denominator of the y squared is just going to be 7 squared. But now to get the denominator here, I need to know what these x-intercepts would be. And I have to get that out of I have to use the foci to help me. So, so we're going to use the foci to help us get that other denominator. And the foci equation is that a squared minus b squared equals c squared. That's how the a squared, b squared, the denominators of the x squared and y squared, that's how they're related to the foci coordinates, right? And so what do we know here? Well, if the y-axis is the major axis, then 7 is the a value. So 7 squared. So 7 is the larger of the a and the b values, minus the b is going to be the basis. The b squared is going to be our denominator for the x squared here, because we know the smaller of those two has to give us our x-intercepts. So 7 squared minus b squared is 5 squared. That's 49 minus b squared equals 25, or 49 minus 25 is b squared after we do some rearranging. 49 minus 25 is 24 is b squared. So b is plus or minus the square root of 24, but actually, you know, we don't have to even simplify. I guess I could simplify that. B is we're going to have plus or minus square root of 4 times 6. So b is plus or minus 2 radical 6, which I think we've seen before in this section somewhere. So those are my x-intercept values for sure, but what we need in the denominator under the x squared is the value of b squared. Now I'm just going to write this as radical 24 squared to remind everybody that we are squaring something there. And when we do that squaring, we have x squared over 24 plus y squared over 49 equals 1. And there's our equation that we need. You could check the intercepts of the equation we found just to see that they coincide with what we think we should be getting. Okay, so there's our equation for number 5, where we had to use the foci to help us find that denominator value for the x squared term. Okay, we have one more problem on ellipses to work on, our number 6. Find an equation for the ellipse centered at 0, 0, symmetric with respect to the x-axis and the y-axis, with one focus at 0, 3, and having negative 2, 0 as a point on the graph. Okay, well wait, now we're given slightly less, I feel like less precise information here about what's going on with this ellipse. So let's see, one focus at 0, 3, 0, 3, think of that as there. There's one focus. The other focus then is going to be at 0, negative 3 because of the symmetry in the center, we're told. Now, I don't know exactly what this shape is going to be. Let's see. We also know negative 2, 0 is actually a point on the ellipse. So I kind of have this idea that my ellipse is going through negative 2, 0. I don't know exactly where it crosses the y-axis, but it's going to be above that focus. It's also going to have positive 2, 0 on the graph. It's also going to wrap around that other focus. So we're trying to find x squared over something plus y squared over something equals 1. We want to fill in these denominators. The denominator for x squared will come from the x-intercept. I know the x-intercept's got to be at 2 and negative 2. So I'm squaring 2. I got that. What I don't have is my y-intercept values, right? We're trying to figure out what these guys are. And so, again, we're going to use the foci, and we're going to use that a squared minus b squared equals c squared equation to see if we can figure out what the y-intercept should be. And now here I got to think about where to put the 2 that's under the x. So the major axis is on the y axis. The minor axis is along the x. That means the 2 squared is our b squared value. You know, the larger intercept number goes first, smaller intercept value goes second here. I just think larger, smaller. So a squared is actually our y, it is based on our y-intercept value. We can think of that as 0a. So a squared minus b squared equals c squared. Focus is at 0,3, so that's 3 squared. A squared minus 4 equals 9. A squared is equal to 9 plus 4 is 13. So A is going to have to be, I'll get plus or minus square root of 13 for my 2 y-intercepts, right? Now I don't actually have to actually plot them here because the problem only asks us for the equation. It's a squared that's going to go underneath the y squared. And again, just like I did before, I just want to emphasize we're taking a square root squared. Let's recopy the answer down here. So when we square those, we get x squared over 4 plus y squared over 13 is what we get after the square root is squared, equals 1. There's the equation of the ellipse that we're looking for in problem number 6, and that's the end of our ellipse exercises.